Continuing on with week 9, here is the example out of Thompson. I do it slightly different than what's in the book, so maybe that's the benefit for me doing it as opposed to just reading the book, but you should read the book. So you have a machine with 100 kilogram mass is supported by springs. It always helps me, it always helps me to draw out what I'm looking at right here. So it's supported by springs. And it has a total stiffness of 700,000 newtons per meter, and it has an unbalanced rotating element. So I like to draw that like this right here, and something like that, which results in a disturbing force, FO, of 350 newtons. So you can start doing this as you do your homework. Then when you get to an exam, and you can start picking the problem apart and maybe understanding it better. That's my opinion. So you can do that or do it your own way, whatever you think is best. But they have a 3,000 RPM, which we know is going to be 2 pi over 60. It's going to be equal to 314.2 radians per second. Assuming they have a damping factor, so there must be dampers in here, of 0.2, we want to find the amplitude of the motion due to the unbalance, the transmissibility, and then the transmitted force. All right, so in any problem, we should probably, that we can, as soon as we can, I didn't write the mass down. As soon as we can, if we have enough information, find the natural frequency. And that should be 83.67 radians per second. And we know that we already have the forcing, so we can find a R of omega F over omega N. That ends up being 3.755. So we have those two pieces of information. We can get right onto it. Now we go and we can jump to the equation we've been using for much of this forced response stuff, which is the FO over K over the square root of 1 minus R squared, quantity squared, plus 2 squiggle R quantity squared. So we have our 350 divided by our 700,000 divided by the square root of 1 minus 3.755 squared plus 2 times 0.2 times 3.755 whole thing squared. And we get an X equal to 3.792 E minus 5 meters, which we could go 0.03792 millimeters. And I always like to try to put it into some type of units that will make, that I can get my head wrapped around. Now we want to get the transmission ratio, or transmissibility, excuse me. And so we could put it right into here, right? Recognize that we might be able to find this instead. So this is another method that we could do. We could find the FT, and we were given the FO, and now, because now we have the X, right? We have the X, and we can just multiply it by these things. Although we don't have C, we could work that backwards and try to find it. Or we could just go with this guy right here. So he might actually be the easiest approach, because we already did a lot of plugging and chugging. So in terms of like maybe approaching an exam problem, that might be an interesting one to kind of try to do it instead of trying to do plug and chug all the way through that thing. This is ever so slightly shorter and would be so maybe be preferred if you're looking to be economizing your time. Or we could just go ahead and write down what I have on my page, which is the pluggy chuggy equation. 2 squiggle r squared, quantity squared, and then over pretty much over the same thing. Still another test taking tip. Maybe if you forecasted that you were going to do that, you would like have saved what that number was previously, or if your calculator is one that saves everything you type in, maybe you could just pull that down if you were to hit as a separate thing, but it's up to you. All right, so I could be a lazy person, and quite often I am, and just tell you, yeah, plug the numbers in and you got the idea. I guess so, but I'm going to keep doing what I do, which is to show you, demonstrate that you don't have to be lazy. You can be a diligent engineer. You don't have to take the shortcuts where all the mistakes happen, in my opinion. It's not that hard to do. It's just not always that pleasant. 0.1368 matches the book's answer, so I'm feeling good about that. Kind of running out of colors. I never use that green. Let's go with that green. And then lastly, of course, honestly, this makes sense. Now that I should have thought about this. We could have gone C first and then found B, and that would have been the shortest route. So I actually kind of did it, right? So we take that ft, and the equation for the ft that we had on the previous page look like this. 1 plus 2 squiggle r squared. So we go 700,000 times our answer up above of 3.792 e minus 5, and then times the square root of 1 plus 2.2, 3.755 squared. Well, whole thing squared, be careful of that parentheses. And we get an Ft equal to 47.90 newtons. And we could check this by taking, if I had enough room, let's see, we want to see, should I go input versus output? Whoops, input versus output, just to make sure I get it right. Ft over Fo. And so that should be, this transmissibility should also be Ft over Fo should be equal to 47.90 divided by 350. Right? And that should also be equal to 0.1378. So that would have been quick. It would have been quicker to do this calculation and that calculation and then do this calculation, right? We would have saved ourselves some time. So that is the end of this video. Let's make some more.